Okay, happy Friday. Today we are going to be writing functions for sine and cosine graphs. Okay, and again, this is just a review for your midterm. So you need to get these pieces copied into your notes as far as how we determine all four pieces that we need in order to make a sine and cosine function. All right, so A, your amplitude. Remember, that's how far the graph is stretched. And you take your max and min y values, subtract them, and divide by 2. Remember, max and min are always your y values. Okay, your vertical shift, how far up the graph has been moved, up or down. And you get that by adding your max and min y values and dividing by 2. All right, B is not your period. Remember that, please. Highlight, underline, star it, or something so that you remember. It is your period variable. It actually determines what your period is going to be because of the formula, period equals 2 pi divided by B. And remember, please, that period is how long it takes for the graph to go through one complete curve. Okay, whether it's sine or cosine doesn't matter. But it's how long it takes for it to go one complete curve, and B is not the period itself. It is the variable that gets us our period, that tells us how fast or slow the curve happens. Okay, and again, same thing for C. C is not your phase shift, it is your phase shift variable. It determines how far left or right your graph is going to move, okay, or basically where it starts. Phase shift is determined by C divided by B, which means if you're given a function or given some information, you got to solve for B first so that you can then use it to solve for C. Okay, and the functions, make sure you've got everything. The functions for sine or cosine, A sine bx minus c plus d, A cosine, again, same exact equations. The only difference is whether it's a sine curve, which remember starts in the middle, goes up, comes back down, goes under, and then comes back to the middle. Even if it's reflected, the sine curve always starts in the middle of the function. Remember, that is your midline, which is the same thing as your vertical shift. Okay, so a sine function always has to follow that pattern. All right, if it's a cosine, again, doesn't matter if it's reflected or not. It always starts, well, it does. If it's not reflected, it starts at the top, goes down, and then comes back up, with that being the midline. Or if it's reflected, it starts at the bottom, goes up, and then comes back down. Again, depending on if it's reflected or not. But a sine function always starts at the middle, and the cosine function either starts at the top or at the bottom. Okay, and that's, how we determine. All right, so I've got about 5 practice problems and then an assignment in Canvas for you to do. And let's get started. And we're just going to pick out the information that we need in order to be able to do this. Okay, so again, amplitude is max minus min divided by 2. So in this case, our maximum is 2. Our minimum is negative 2, right? Max minus min divided by 2. And that means our amplitude is going to be 4 divided by 2, which is 2. So our A value, our amplitude is 2. Okay, same thing, just to prove that it in fact does, start at 0 like we think it does. So 2 plus negative 2 divided by 2. So max plus min divided by 2. So that's going to be 0 divided by 2, which is in fact 0. So there is no vertical shift. It does actually start at 0 like we think from the equation. Okay, we're going to call this a sine function, and we're going to say that this, all the way back to the middle, is our period. That's one full curve of the sine function. So our period, from 0 to pi, our period is pi. Okay, so our period is pi. That means we actually need to figure out what b is based on that. Okay, so remember, period equals 2 pi divided by b. Okay, so that means that in order to solve for b, we do pi equals 2 pi divided by b. How do we solve for b from that? You can think about this as pi over 1, right? And we can cross multiply. This would be 2 pi equals pi b. Right? And then we would divide both sides by pi in order to get it. So let's show dividing. And we would divide by pi on both sides. So that means that b equals 2. So we have used our period to find our b variable, okay? And that makes sense because if the period is 2 pi divided by whatever b is, it kind of shortens it or lengthens the period. So 2 pi divided by 2 is pi, which is how long the graph takes to make one full curve. Okay, phase shift. Well, our phase shift in this case is nothing because the graph does start at 0. All right, let's just say, for instance, what if we wanted this part of the graph and that's where it started? Well, it would have started at pi, okay? So then you would do your phase shift is pi equals c divided by 2, right? And then you would put in your, you would solve for actually for c that way, and that would give you a phase shift. Okay, if you actually have a phase shift that happens. In our case, for this equation, our phase shift is 0. We have other ones we're going to be doing that it's not 0. Okay, so if the phase shift is 0, we can still, solve for c if you really want to see it. It's going to be 0 equals c divided by 2. And that means c is going to equal 0 because, cross multiply 2 times 0. So let's go ahead and write the equation with everything we've got. All right, so y equals, our amplitude is 2. It is a sine function. B was 2. Our phase shift is 0. So if you want to type in or write in the minus 0. And then plus 0 is our vertical shift. So that would simplify. And you could just call this y equals 2 sine 2x. And that would be the equation for that graph. All right. So now we have a cosine function. Unless you want to make this a sine function, and you can. The nice part about this is that it is a choice. If I wanted to make this a sine function, I would have to figure out a starting point like here to here. And that would be probably a little bit harder, but you could do half of pi over 2, which would be pi over 4. So you could actually start it as a sine function if you wanted to. Let's see. You could start it here and do a negative sine function. But easiest on this case, since we can say it starts at 0 on the top, that we can call this a cosine function instead. Okay, so we're going to call this a cosine function. And amplitude, well, our minimum is 0 and our maximum is 6. So we do max minus min divided by 2, and that's going to be 3. So my amplitude is 3. Okay, so same thing, vertical shift, only now we're adding 6 plus 0 divided by 2. equals 3 as well. So my vertical shift, my midline, is actually here at 3 instead of at 0 where it's supposed to start, or at 0 where it's supposed to be, rather. Okay, so that is our midline. All right, period. How long for it to go through one full curve? Pi. Okay, so if our period is pi, well, do the same thing. I know it seems tedious, but do the same thing again. Period equals 2 pi divided by b. And you'll do your cross multiplying. 2 pi equals pi b. And then you'll divide, which means that b equals 2. Okay, phase shift, again, no phase shift. It does start at 0, so we don't have to worry about that part. And we could solve for c, but we know c would be 0. So let's go ahead and write our equation. Again, y equals amplitude 3. This is a cosine function, and our b is 2, so 2x. No phase shift, so c is 0, so minus 0 if you want to put that in, and then plus 3 for the vertical shift. And if you want to simplify it, 3 cosine 2x plus 3. Okay, so let's see. Next one. All right, so we're starting at negative 2 pi, and the graph goes to positive 2 pi. So we can actually choose to start it at negative 2 pi, or we can choose to start it at 0. Since this is obviously going to be a sine function, it does start in the middle. A couple of choices on how you want to do this. Again, if you want to pick this one, that means there'll be no phase shift, right? And if you want to start over here, note please it's starting at negative 2 pi, right? This is the 0 boundary here. If it starts at negative 2 pi, you're going to have to do a phase shift on it. Okay, so you need to make sure you're aware of how high or where your graph is starting. By the way, 1, 2, 3, 4. Oh, wait, they've got it marked on the side. Okay, so the graph is starting at 2 on the height, goes up to 3, and down to 1. Okay, so highest minus lowest divided by 2. Amplitude is 1. All right, vertical shift, max plus min divided by 2 equals 2. That means our graph is starting at vertical shift of positive 2, which means its midline is here, right, as opposed to being at 0. Okay, period. If we go from here, the period is, oh, good luck, 2 pi. Okay, so again, do your solving. Okay, 2 pi equals, no, let's try that one again. Yeah, 2 pi equals 2 pi divided by b, since your period equals 2 pi divided by b. That means that b equals 1. We haven't changed the period at all, so we can just say b equals 1. And again, phase shift is 0. All right, so writing it, y equals 1 sine, b is 1, 1x, minus 0 plus 2. Simplify that all the way down. Y equals sine x plus 2. So it's been vertically shifted to regular sine function. Okay. Next one. We've got another, well, yeah, I'd say this would be another cosine function, simply because if we want to choose a starting point that's actually on a number that's tagged, it makes life a little bit easier. You could call it a negative cosine function if you wanted to start here and go to here. That would be fine. In fact, you know what? Let's do that. Let's treat this as a negative cosine function. So we can start at 0 and not have a phase shift. And then we'll go back and we'll do one with a phase shift, starting it here and going to here. Okay? And both of them will be representations of the graph. Okay, so highest minus lowest. So 2 minus negative 4. 4 divided by 2 should give me an amplitude of 3. 3 in either direction from the midline. All right, and then highest plus lowest divided by 2 should give me negative 1, which seems reasonable that that is the midline, negative 1. Okay, the period. Starting at this one, if I'm going from 0 to pi, okay, my period is pi. So we're going to do pi equals 2 pi divided by b. And it's the same thing that we've been seeing all along. Going to do your dividing. 2 pi equals pi b, which means b equals 2. And for the first one, we're going to say that the phase shift is nothing. So going with the purple, I'm going to type this in purple so you can catch it. Y, let's try that again. Purple. Y, no, you're still not. Okay, there we go. All right, Y equals, amplitude was 3. And we know it's a negative because it's facing upside down, so it's actually negative 3. Cosine b is 2, so 2x minus 0, 0. And the vertical shift is down 1. So that being simplified, y equals negative 3 cosine 2x minus 1. All right, and we'll do the other one in green just so you can see the difference. That is the equation for the purple one right here. All right, so let's try the green one. Slide that over. Okay, so amplitude is still going to be 3. The vertical shift is still going to be 1. Period is still going to be pi, so b equals 2. Here's where the phase shift comes in. All right, just to show the difference in here. This graph now starts at pi over 2 and is positive. So if our phase shift is pi divided by 2, we need to do some solving so we can solve for c. Okay, so phase shift, pi, where are you at? All right, pi over 2 equals, good grief, there we go, equals c divided by b. Well, b is 2, right? So we're going to cross multiply to solve for c, and that is going to get me 2 pi equals 2c. Pi equals 2. I know it's probably harder to read if this is not as a stacked fraction, so let me see if I can stack it up for you. Okay, so yeah, pi over 2 equals c over 2, if that makes life a little bit easier for you. Cross multiply, you get 2 pi equals 2c. Divide by 2 in order to solve for c. So c equals pi. Okay, now if we're going to type this one, and again, that's the only difference other than the fact that the amplitude or the graph is now positive, okay, would be typed up like this. And both of them would actually be considered correct, which is the nice part. So 3 cosine, that's still 2x. The only difference now is that you have a horizontal or phase shift. And by the way, this works just like any other graph that you did back in, last year's class. If it's shifting to the right, it's backwards because the original equation already has a minus. So it's minus pi, right, minus 1. And if you were to graph both of these equations in your calculator, you would get the exact same graph. So, and if you want to try it, go right ahead. But you can put both of them in the same, into your graph, and you're only going to get one line. Just please be sure that your equation or your calculator is in radian mode. Otherwise, you know, bad things are going to happen. So, yep, if you're trying it out, we got one more example to do. Again, you know, make sure your graph is in radian mode, otherwise it's going to be pretty difficult, or it's not going to look like an actual graph at all at that point. But if you graph both of them in your calculator in radian mode, you will all you will get is one line because it's the exact same graph. Okay, last example. And I wanted to do this one because it has whole numbers instead of radians or anything like that. And remember, we always deal with real number graphs where it's not, you know, hitting at pi and pi over 2 and all that kind of stuff. So I wanted to show you that, or remind you rather, that we can write these graphs. Okay, I'm going to treat this one like a sine function because to me, if I get it to start here, that does look like it's the middle. That seems to be a little bit easier to work with. And that would be your full curve. Now, if you can't see this, this is -1 here. Okay, where it starts, so we have our phase shift, and that's good. Over here, this looks like 5 1/4. And the reason I say it's like 5 1/4 is because 5 is right here, right? And 6 is right here. And that doesn't look like it's halfway. So we're going to call that 5.25 or 5 1/4. If you're having some confusion as far as why that is, take a look. I mean, this thing it's kind of hard to see, I know, but it is gridded where there are 4 squares between each number. Okay, so we're just going to call that 5 1/4 so that we can actually have our period and all that kind of stuff. All right, so our max is at 3. Our minimum is at -3. Right? So let's go ahead and find our amplitude and our vertical shift. So again, max minus min divided by 2. Amplitude is 3. Okay, max plus min divided by 2 equals our vertical shift, which is 0 in this case. All right, so the period, how long for it to take one full curve? Okay, so if it starts at -1 and it goes all the way to 5.25, how many squares or how many units would that be? Well, you can also do end minus beginning if you want to know what your period would be. In this case, it would be 5.25 minus -1, which gives me a period of 6.25. Okay, so we need to do some work with that as far as to find our period variable. Okay, so period equals 2 pi. And you know what? I'm going to make this a stacked fraction just to make it easier to see. 2 pi divided by b. And we can treat 6.25, we've talked about this before, I keep reminding y'all, as if it's over 1. Right? Just to make life easier as far as cross multiplying. So we should get 6.25b equals 2 pi. Okay, So then we have to divide by 6.25 on both sides. So 6.25, and you're going to get a decimal, and it's okay. 0.25, and whatever the heck 2 pi divided by 6.25 is. So let's find out. 2 pi divided by 6.25 equals 1.005. So B equals 1.005. And no, we cannot count that as 1. It's not. Because it's not starting at negative 1.25 or wherever else. We're just going to count that as 1.005. Okay, phase shift is -1. So let's solve for C. -1 equals C. Let's try that again. C divided by 1.005. So cross multiply to solve. C is going to equal -1.005. Okay, and we're going to put it all together into an equation. So y equals, and our equation goes up instead of down, so it's not a negative, thank goodness. So y equals, amplitude is 3. Sine and b is 1.005 x. And since our phase shift is negative, it goes positive in the equation. And there is no vertical shift, so it's +0. So that's the actual equation. Okay, so you need to get used to dealing with real world ones where your graph is not split into radians. Okay, so your assignment is in Canvas. It is called, let's see. Canvas. There we go. I think I already put it in there. I think it's graphs of sinusoidal functions, but let's make sure. And sine graphs. Okay, and go ahead and get started on that now. Like I said, it's in Canvas. It's called sine graphs. I think there are 4 on there that you have to write the equations for. All right, talk to you later. Bye.